The objective of this video is to describe the security functions a router can provide. So in my school we often do this philosophy first thing where we just get a nice reminder of the bigger and more important things in life, and so I found this meme and thought I'd use it for today. It says when the teacher uses your assignment as an example for what to do right. Isn't that a great feeling? So there will be many opportunities for you here to write something amazing for me to share with the whole class. Now, the table of contents goes like this. The first thing I want to do is connect this lesson with what we talked about last time, and then we'll talk about routers and their position in the OSI model. Next up would be security features and flaws of routers. Then I'm going to clarify what a modem is compared to the router, and then clarify what the concept of an internet backbone is. Next up, I'll offer an extension activity, and the last thing will be a small preview of switches and hubs. So basically, this lesson is just all about routers. And you might think to yourself, how can an entire lesson be on just routers where, well, they're a little more complicated than you might have initially thought? To start with, last time we talked about the difference between ports and sockets, and this is a little like asking what the difference between a hotel door and the handle of the door is. Now, once sockets have been created and the connections between processes have been established, using sockets have the same characteristics as reading and writing files. So there's this thing called the PID number, and it's used internally for your computer to refer to a specific process. Now, a processor, that's your CPU, can only do one thing at a time, even if it can do a billion things within a second, thus the word gigahertz. At the end of the day, it can only do one single thing in a single microsecond. So with that said, it's difficult because there's multiple tasks that we ask the processor to do. So what the computer does is it alternates between working on one process and another one. The PID is the tag that the processor uses to identify each process. And my go-to example for this would be on Google Chrome. If you're using Chrome as a browser, that has the option to make each tab an individual process. So you can be on one tab watching a video or maybe listening to music from YouTube like I do, and then you're on another tab at the same time, but you're doing some work or something on that other tab. So those are two distinct individual processes. And it makes sense now why the computer would need to differentiate between those two tabs, because you don't need data for your work being sent to the YouTube channel or the music that you're listening to. You don't want these two things to get mixed up. So your think, write, share here is, what is a PID? So with that said, the socket number is a tag given to all network communications, so that when an answer returns from the network, that is to say the internet, the router on your home network knows what computer awaits that answer. And when the answer arrives, the computer knows which process awaits the message. So this last sentence might frustrate you if you don't understand the concept of a bus. So that's to say just electricity sitting on a certain section of the motherboard, or wire just waiting to be read. So if you want to learn more about that, I really suggest you watch Ben Eater's videos on how to build an 8-bit computer. Even though people don't use 8-bit computers anymore, that is a great way to understand what's actually happening on the physical level, the electrical level, and then you'll be able to connect that to the higher levels that we'll go into in this course. So your think, write, share on this slide is, what piece of hardware is responsible for connecting your home network to the internet? And that's a bit of a trick question. You'll see why later. But for now, let me just walk you through the process of getting something on the internet. Here's our OSI model. You should know this pretty well by now. And starting at the highest level, layer 7, let's say that right here, application process 1, let's say this is maybe a Facebook server. And let's say there's a picture on the server. So the single picture has this much data. So now if I am over here and if I send a request and say I want to, access that picture, maybe I click on someone's profile and the picture is the thing that pops up. Well, here's the process or the path it would take. That picture would then be encrypted, so that if somebody intercepts it down here, the encryption will keep them from seeing what the picture is, especially if it's a private picture or a picture you don't want a lot of people to see. This is a good thing. So at the presentation layer, we're encrypting, and then it will be assigned a session ID number and then a packet number for the TCP idea that data is broken into many packets, and then you have to assign each packet a number so the other computer can like reorganize that. So anyways, there's the packet number. Then it goes down to the network layer where maybe the MAC address is connected to this data. Oops, I mixed those two up. So at the data link layer, you could assign a MAC address. Over here on the network layer, you would have an IP number. So we've talked about IP numbers. With the IP number and a port number, you make a socket. So, okay, going down here, now we have a MAC address and even maybe a cyclic check for redundancy. Like this is something that happens to make sure there are no errors in the data, and then it hits the physical layer, and this part kind of confuses me. I don't know what additional data would be added to the physical layer. And when I say data, I'm talking about ones and zeros. So, what is this thing here? But just skip that for now. Moving on. Now we send all these numbers, all these ones and zeros. We send through a wire or the air until we get to this part, and then it's just put back together again. So here comes the data, the MAC address is figured out, then comes the IP, then the TCP packet number, then the session layer, then the presentation layer. It is decrypted. So there was encryption before, now it's decrypted, and now you're back at the application layer where you can actually see the photo. So I did all that narration just so you can try to do the same. So to the best of your ability, go ahead and write down what happens if you're trying to do something simple like just get a picture from a website such as facebook.com. So after that exercise, I want you to predict where on the OSI model would you imagine a router would go. So if a router is in charge of connecting the right computer to your computer, or the right server to your computer, where in this model do you think you would find that? Well, let me tell you a little bit more about routers so you can maybe make a more informed decision. It says a router may include a firewall, VPN handling, and other security functions, or these may be handled by separate devices. So your think right here is, what do you remember about firewalls? That was about 2 lessons ago. Now, many companies produce security-oriented routers, so this could include Cisco's PIX series or Cisco's Meraki MX series, even Juniper's NetScreen. Now, below is an MX600 right here, and then this one is the Jupiter NetScreen one. And look at the price on both of these. They're pretty expensive. So you're likely only using a router like this at a data center where servers are kept. Now, routers also commonly perform network address translation. So what this does is it allows multiple devices on a network to share a single public IP address. So that's something for you to think about when you're at your house. If you have a big family like I do, I have 3 kids and they are all on a device at the same time sometimes. So like I have those 3 devices, me and my wife might be on a device or accessing the internet. So that's already 5 separate requests for things off the internet. So inside my house, all 5 IP addresses are reassigned a single IP address to send out to the internet. And then once those requests come back, it's my router or modem's job to divide that data into the place that it's supposed to go. So that concept's called NAT, also known as Network Address Translation. Another thing routers do is stateful packet inspection. And we talked a lot about that when we talked about firewalls. So I'm not going to go into the details of that, but your think right here is with everything I just said, what's the difference between a router and a firewall? And if you have to go back to your notes on firewalls, definitely do that. Now, some experts argue that open source routers are more secure and reliable than closed source routers because open source routers allow mistakes to be quickly found and corrected. So one of the most famous open source firewalls is pfSense. And if you're worried about security at your house, or maybe your parents' business, if they have one, you can go ahead and do some additional research right here because that might be a great option for you guys. Okay, so a couple more things about routers, so you could try to figure out where on the OSI model a router would be. Now it says a router in a local area network of a single organization is called an interior router. So that would be maybe an example of your own home. If you have a router, it's an interior one. And I'm thinking absolutely like everyone has a router at their house. I just can't imagine a modern home in this day and age without one. Now, an exterior router directs packets between hosts in one LAN and hosts in another LAN. So a router that is operated on the internet backbone is an exterior router. We talk about this in my AP computer science class a lot. The internet backbone is where a lot of requests for web pages find themselves, and then those requests are routed to the correct server. Now think home versus data center when you think of interior versus exterior routers. And with that said, a lot of people at their own homes confuse a router with a modem, so let me clarify that for you. A modem is for the internet. It's used for communicating between an ISP and an endpoint, and usually your home is the endpoint. And it's a little different than a router in the sense that it stands for modulator demodulator, so thus modem, and its function is to convert the digital signals of your computer data into electrical signals that go over your cable or DSL connection to the ISP. And it is typically a one-to-one, so one modem connects to one device. That's where the router comes in. Your modem may have a router built in, and I have heard different opinions about this, but Leo Laporte from the Tech Guy Show, he says it's not good to have a router inside your modem, that you should keep those two separate, and I can understand why he says that. For years, I got along just fine without having them separate, but as of now, I do have them separate. So with that said, that's the primary purpose of a modem, is to take the ones and zeros that you're giving and receiving, to take those ones and zeros and make them acceptable for long distance transmission. We could be talking about going over fiber optics or telephone wires or coaxial cables. There's all kinds of different mediums your data may go through, and that's why you would need a modem in the first place. So while you're thinking about that, I want to know, who is your ISP? In the city of Colorado Springs, where me and my students live, this is going to be one of two companies. And sad to say, a lot of places in the country only has one ISP to offer. So that's a controversial kind of political, social debate or discussion we can have. A lot of people have this opinion that ISPs should actually just be like utility companies. And I think there are a lot of good arguments for that. So now moving on to the router's specific difference between a modem. It's more like a stoplight at a large intersection. It helps to manage your internal network of 1 to 100 computers so that those computers can communicate with each other. It is typically a 1 to many kind of ratio. So one router connects to many devices. And down here you can see in red, I circled the telephone line going in. This is going to be an RJ11 connection, and that's how the internet gets to the router. And this might be a modem as well. In fact, I'm assuming this picture is one of those examples of a modem and router combined, because here's the ISP line going directly in, so then it changes modes here from the telephone type signals to an Ethernet cord or a Wi-Fi signal here with the antenna. So your extra credit here is to look at your modem or router at home and see if you're connecting to a telephone line or maybe a coaxial cable. And depending on what your answer here is, I could tell you what company you're getting services from. So your Think Right Share on this page is, in your house, do you have a router inside of your modem? So that is a box the ISP likely gave or rented to you. Or are they separate? Now to check, all you have to do is see if that box is connected to another box, which would presumably be the router. And this little antenna thing is nice because it should be a sure sign that you're looking at a router. But not all routers have antennas. Mine does not. So in that case, you just have to look at those two ports. And I'm not talking about port numbers. I'm talking about actual physical ports there. So the modem is about connecting a single endpoint to the internet. The router is more about connecting multiple endpoints within a network that may not be connected to the internet. So when you combine a router and a modem, you create a connection where communication can occur between the private network and the internet itself. So your Think Right Share here is, what is the difference between a modem and a router? So last thing I'll say about that is routers route and modems mode, which reminds me of this quote from Einstein: everybody is a genius, but if you judge a fish by its ability to climb a tree, it will live its whole life believing that it is stupid. If a modem is not a router, that's perfectly fine, because its job is to just change the mode of those digital signals that it's receiving. And then think about this. All Android smartphones can be turned into a modem. Knowing how to share your smartphone's internet connection can get you out of some sticky situations as well. And all Android smartphones can generate a wireless Wi-Fi hotspot. So here's a picture of a computer connecting to a Galaxy Nexus phone, and you can see all these details right here, including an address for the router itself. So I was thinking, why would you need to know the IP address of a router in order to connect to the internet? These are a lot of numbers, and then we have never talked about subnet masks, not even in that AP class. The more you learn about networking, the sooner we'll get to what a subnet mask is, but that's just more than what we need right now. Okay, just a heads up, the next 3 slides are just some cool additional information, and I'm not going to even read these or go over them, but you could pause on each of these if you wanted to learn more. And the last one's cool. It's kind of my old history teacher self getting involved here in the tech lessons. I think it's just cool to see the history of computers, and here's the very first ARPANET router. And I think it's just interesting how crazy routers have changed, or at least this giant box is basically this little baby box nowadays. And if you're really interested in networking, it is a cool topic. I would recommend you listen to a podcast called Data Knots. And also, I thought you might enjoy seeing the first hits I got when I searched on Indeed.com for network security jobs. So if you combine what you learn in this class with details and knowledge from a networking standpoint, there's some pretty good paying jobs out there. And for us in Colorado Springs, this is pretty close. So the last piece of information I want to give you before we do the DOL is just that there are other devices that you might get confused with. I doubt you would have these at home, but maybe, you never know. To go over these, I think just using an analogy of how people can communicate maybe at a party would be a good approach. So the hub, or a hub, is like a room full of people where everybody holds up huge signs with messages written on them that are only meant for one person to read. So everybody else has to read each sign to see if it was meant for them. So that's what like a hub is. And then you have another device called a switch, and that's like if everybody in the room passed notes to each other, and you only pass the note to the person you want to read the message. So it may be hectic, but it's one way of delivering information. And now a router is like a man or woman who stands at the door of the room full of people, and they just give them a note, and you just give them a note, and they give it to the person who you wanted to read it. So sort of a streamlined, much more efficient way of requesting and receiving information. All right, so we're in IB school, and the question is, what will these look like? What will we see if cybersecurity experts are inquirers or open-minded or caring? Like the information you learned today, which one of these attributes, IB attributes, would that connect with? Here's the DOL. It says all modern Wi-Fi routers provide a variety of encryption choices that are used to make traffic unintelligible to anyone trying to sniff packets out of the air. Give me 2 details that make routers helpful to establish security over a network. And if you're interested in some more individual learning here and you're not a part of a discussion group today or whatever, here's an extension I'd suggest to you. Go ahead and research more jobs related to network security and let me know what you find. Tell me what you find that's interesting or surprising about that research. And that's it. Thank you for learning with me.